Hello, friends. Grab your coffee, grab your cookie, and today, keep both far away from any tobacco cutting line because we are talking about tobacco dust. Yes, the fine, fragrant, sticky organic powder that comes from shredding, cutting, drying, blending, and transporting tobacco leaves. It looks harmless, but it is allergenic, combustible, and full of biologically active compounds like nicotine. My name is Michael Klepik, and for 15 years I have been designing dust collection and air filtration systems for agricultural processing, tobacco manufacturing, cigarette production, cigar facilities, and flavoring lines. Let me show you why tobacco dust requires serious engineering and safety controls. What tobacco dust really is, technical description. Tobacco dust consists of particles generated from dried and processed tobacco leaves. Technically, first, particle sizes typically range from 1 micron to 100 microns. Second, the airborne fraction from 1 micron to 20 microns is the most hazardous. Third, bulk density ranges from 150 to 400 kilograms per cubic meter. Fourth, tobacco dust contains nicotine, cellulose fibers, volatile organic compounds, sugars, and plant resins. Fifth, fine particles carry strong odor and migrate rapidly through air. Tobacco dust behaves like a combination of plant fiber, chemical aerosol, and combustible particulate. Where tobacco dust appears in industry. Tobacco dust is generated in, first, leaf cutting, shredding, and primary processing. Second, drying, curing, and conditioning lines. Third, blending and flavoring operations. Fourth, cigarette and cigar manufacturing. Fifth, conveying, screening, and sifting stations. Sixth, seventh, tobacco product recycling or reprocessing. If tobacco is moved, cut, or dried, dust appears. Why tobacco dust is dangerous? Tobacco dust poses several hazards, health hazards. First, nicotine is absorbed through respiratory pathways in skin. Second, dust triggers asthma, allergies, and green tobacco sickness. Third, plant fibers irritate the respiratory system. Fourth, dust carries microbials, spores, and residual pesticides. Fifth, OSHA considers tobacco processing a high-exposure industry. Equipment hazards. First, tobacco dust is organic and highly combustible. Second, it accumulates static charges during transport. Third, sticky particles coat sensors, belts, and electronics. Fourth, moisture in tobacco increases microbial growth and corrosion. Fifth, dust layers dramatically increase fire risk. This is not just plant dust. It is chemically active organic particulate. Combustibility. NFPA recognition. Tobacco dust is classified as a combustible particulate solid under NFPA 652, NFPA 654. Reasons. First, particle size is well below 500 microns. Second, organic materials ignite quickly when airborne. Third, static discharge from conveyors ignites dust clouds. Fourth, dry fibers burn rapidly and unpredictably. Fifth, dust layers amplify explosion severity. Many fires in tobacco factories start inside dust collectors. Behavior of tobacco dust in airflow. From an engineering perspective, first, tobacco dust is extremely light and remains airborne easily. Second, cigarette cut filler creates long fibers that resist normal airflow. Third, sticky plant resins make dust cling to surfaces. Fourth, moisture content affects dust mobility and microbial growth. Fifth, fine particulate penetrates deep into standard filters. For tobacco, I typically design duct velocities from 3,500 to 5,000 feet per minute. Filtration equipment that works best, FOEHN cartridge collector, ideal for fine airborne tobacco dust. First, membrane cartridges capture submicron organic particles. Second, conductive media reduce static charge. Third, strong pulse cleaning prevents early clogging. Baghouse Blizzard best for fibrous dust and heavy loading. First, rugged bags handle long tobacco fibers. Second, good for primary shredding and processing lines. Third, pre-separation protects bag filters from fiber clumping. Industry-specific concerns. Static dissipation is critical. Stainless steel contact surfaces, easy clean design for sugar and resin contamination, optional HEPA, final stage for odor-sensitive zones. Regulatory compliance, OSHA and NFPA OSHA tobacco processing facilities fall under, first, general duty clause for combustible dust, second, requirements for ventilation and airborne nicotine control, third, PPE and respiratory protection standards, fourth, hazard communication for plant-derived dusts, fifth, required dust hazard analysis for combustible particulate solids. NFPA tobacco dust is covered by: first, NFPA 652 combustible dust fundamentals; second, NFPA 654 prevention of fire and dust explosions; third, NFPA 68 explosion venting rules; fourth, NFPA 69 explosion isolation. Compliance is essential due to high organic dust fire risk. Dust collector system requirements for tobacco. Tobacco dust is extremely light, fibrous, sticky, and carries nicotine. So the dust collector system must be engineered as a complete automated unit rather than just a source capture hood. I designed, first, a differential pressure sensor to constantly monitor the condition of filter bags or cartridges. This prevents overloading and alerts the operator before a failure occurs. Second, an automated hopper discharge system, because emptying tobacco dust manually is inefficient and increases worker exposure. Automatic rotary valves or screw conveyors reduce labor and improve safety. Third, collection into super sacks, because tobacco dust is light and fills bags quickly without overloading structural components. Fourth, a sealed hopper with steep walls to prevent dust buildup and bridging, since tobacco fibers tend to form clumps. Fifth, an anti-static and fully grounded dust collector body, because tobacco dust develops strong static charge during conveying and separation. Sixth, explosion protection elements, such as explosion vents or isolation valves, when the dust hazard analysis confirms combustible characteristics. Seventh, a maintenance-friendly design with large access doors, smooth interior surfaces, and easy filter replacement to reduce downtime and contamination risks. This system-level approach ensures stable operation, protects filter media, minimizes worker exposure, and keeps tobacco dust contained from start to finish. Tobacco dust may look like a natural plant powder, but it is allergenic, sticky, combustible, nicotine-bearing, and capable of igniting under NFPA conditions. With proper airflow, high-efficiency filtration, anti-static design, and strict OSHA and NFPA compliance, we can safely manage tobacco dust and protect both workers and equipment. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, tobacco belongs in the product, not floating inside your ductwork. See you in the next video.